This is problem 6-105. We have a square cross section here that's 250 millimeters by 250 millimeters. We're being subjected with a moment of 850 Newton meters. It's going at this angle here. It's around this axis running along here, this in the YZ plane. We want to determine the stress at each corner and sketch the stress distribution produced by the moment. Angle here is 30 degrees, so we'll go ahead and show that as 30 degrees here. Now if the moment's going this way, when I get rid of this crack, it means it's going to go this direction here when I go around the Y, and then if I go back around the Z, it's also going to go this direction here. Alright, to calculate the moment, again this is pretty easy. So the moment around Y is going to be nothing more than 850 times the cosine of 30. And when we do that value, we'll get a value of about 736.12 Newton meters. Now we take the moment around Z, and we'll get 850 times the sine of 30. That'll give me a value of 425. Alright, now they're running through the center here, so all we want to do is find the moment inertia about this axis here. And we're going to do that when we consider the moment around Y. So all we're really doing is we're using this equation here. The stress or bending stress is going to equal to the moment times the C distance, which is distance from the center out to the outer fiber, divided by the value of I. Alright, this thing is symmetrical. So if I'm trying to find the moment around this axis right here, I is going to equal to 1/12 this distance here cubed. So run that number, and that's going to be 0.25 cubed. And then times the base here, which is also going to be 0.250. And that gives us a value of about 0.3255 times 10 to the minus 3. Okay, so now let's talk about what's happening with the moment m. If we draw ourselves like a square here. So what we're doing is we're looking down on this part right now just like this. We're looking straight down on it like this in this picture here. This is the y-axis right here. Okay, as a result of this will cause, when we're talking about the moment, we're going to get, so we'll get compression here, and that's going to be point D. We'll get compression here, which is point A. Up here and up here we're going to get tension, and that's going to be E and B. And the reason being is, you think about this moment is going this direction, like this around Y, so it's going to push down here, and it's going to pull up here and here. So now we can go ahead and find out what those moments would be. Use the equation. It's going to equal to MC times I. MC over I. So we get our moment, and that's going to be 736.12. Our C value is going to be distance from here up. This is 250 millimeters. So it'd be 0.125 from here to here, and also be 0.125 down from here to here. So we'll just go ahead and put 1.125, and now all we have to do is divide that by the moment inertia, which is going to be 0.3255 times 10 to the minus 3. Grab the calculator real quick. We'll run that value there. 736.12 times 0.125. Divide by 0.3255 times 10 to the minus 3. and that's going to give me a value I think of about 282,688.172. Okay, so that's going to be the stress. Again, you're going to get compression here, and you're going to get tension here. Now we'll do the same thing for the Y. We'll come down here. We'll draw ourselves another square like this. And now we're going to draw our Z-axis coming up. It's kind of like this. Move us a little bit closer to the center. Now we go back to our picture, and we can tell that we're going or bending this way here. That means this is going to go this way here, which means we're going to get compression here, compression here. We'll get tension here, and we'll get tension here. Get a different color. We'll go ahead and label these again. That's going to be point B. In the picture, we got E here. We have A here. We have D here. We'll just go ahead and run the value real quick. So we run that value. We go back and we use the moment around Z, which will be 425. Times 0.125 over 0.3255 times 10 to the minus 3. Run that value real quick. 425 times 0.125 divided by, in parentheses, 0.3255 times 10 to the minus 3. That gives us a value of 163,210.44. Say 6 right there. Alright, so now if I want to find out what's taking place at A, do A stress here. Now here we have compression, here we have tension, so anything that's in compression would be negative. So that value should be negative 2, use these values here, 282,688.172, make that negative, plus this value here, put the comma there, 63.210.446. Run that value, see what we get. Minus 282,688.172. That gives us a value of about negative 119,478.7. Alright, so what we can do then, just to say this value is going to be a negative 119, and that's going to be kilopascals, or 1,000 newtons per meter. Alright, now we follow the same approach to find B. We'll just mark all these down. B, and we're doing D, and then the stress of D. And again, I think this is the best approach to do these problems. Solution manuals are a little bit different on this. Okay, so let's talk about B. We got B here, we got tension and tension. So in this case here, all we're going to do is add these two together. And when we do that, that'll give us the 446 kilopascals. We come to D. We look at D, we got compression, compression. So we just make them both negative. We look at E. We got tension here and compression here, so we're going to make this one positive and make this one negative. And when we do that, we will get 119 kilopascal. Again, if you take your time and just lay it out just like this, it's really difficult to make mistakes. I think it's much better to do it this approach than deciding where you're going to let the C bars be negative and positive. All right. So that's a conclusion to 6-105.